Okay, guys, let's speak on probability. We all know that the concept probability can be defined as the possible, the possible, the possible outcome of an event happening. Probability that are certain attempt to be one, which means that there is nothing impossible about that probability. And for other probabilities that may or may not happen, they are tend to be in between 0 and 1. So probability, as we all know, that when you are to solve for probability, we'll say the total possible outcome, total outcome over possible outcome. What is the probability that when you throw a a coin that has the head and the tail, which is like the front and the back, when you throw a coin that has the head and the tail, what is the probability that you get the tail? The total the total outcome for a coin is 2 because it has just two faces. But now you are trying to say for the tail, which is just one part of the faces, that should be 1/2, and the probability for that is simply half. So we can define probability in many ways. Now there is a question before us that says a man travels to work either by car or by train. There is a probability of 2/3 that he travels by train on Monday. You should pay close attention to all the details that has been given to us in this question. 2/3 probability of traveling to work by there is a probability of 2/3 that he travels by train on Monday. Traveling by train on Monday. Probability of train on Monday is equals to 2/3. 2/3. If he travels by train on any one day, take note, this probability can be solved in different ways. We can actually use the tree diagram, but I will show you the way we solve it without using a tree diagram. Now pay close attention to the question. It said if he travels by train on any one day, there is a probability of 3/4 that he will travel by car the next day. If he travels by car on any one day, there is a probability of 5/6 that he will travel by train the next day. What this actually means that if you are traveled by car on Tuesday, there will be a probability that he travels by train 5/6 that he travels by train on Wednesday, which is the next day. Now, the first question says find the probability that he travels by car on Tuesday, by train on Tuesday, by car on Wednesday, by train on Wednesday. Now, I would love to show you how he can actually travel on Monday, Tuesday, and Wednesday. On Monday, it is said that on Monday, it is said that from the question, either by car or by train. A man travels to work either by car or by train. There's a probability of 2/3 that he travels by train on Monday. On Monday, we should assume as the first day now. On Monday is either he travels by car or he travels by train. This is the possible way he can travel on Monday. How about Tuesday? On Tuesday, since he may travel by car on Monday, we would say by car on Monday, he can as well travel by car on Tuesday. That is, we are not ending there. And also, if he travels by car on Monday, this is Monday, he can as well travel by train on Tuesday. These are the possible way he can travel on Tuesday. I'm not ending there. If he travels by train on Monday, he can as well travel by car on Tuesday. If he travels by train on Monday, he can also travel by train on Tuesday. These are the 4 possible ways he can travel on Tuesday after Monday. Now for Wednesday, when writing this down, you are not going to draw the tree diagram. For Wednesday, if he travels by car on Monday and travels by car on Tuesday, he can also travel by car on Wednesday. This is for Wednesday. He can also travel by car on Wednesday. If he travels by car on Monday and also travel by car on Tuesday, he can travel by train on Wednesday. This is for Wednesday. This is for Tuesday, this is for Tuesday, this is for Tuesday, and this is for Tuesday. This is for Monday. And this And this last one for Wednesday, for Wednesday, this has a comma. Now, for the next one, if he travels by car on Monday, he can as well travel by train on Tuesday and travel by car on Wednesday. We are not ending here. If he travels by car, you have to find the possible ways. This should end by it. This should be up to 8. You have to find the 8 possible ways. If he travels by car on Monday, he can travel by train on Tuesday and again travel by train on Wednesday. For the next one, if he travels by train on Monday, he can travel by car on Tuesday and as well travel by car on Wednesday. If he travels by train on Monday, he can travel by train on Tuesday, no, by car on Tuesday and travel by train on Wednesday. The next one, train on Monday, train on Tuesday, and car on Wednesday. The next one, train on Monday, train on Tuesday, and also train on Wednesday. I don't think from here there are any other possible ways he can travel on Wednesday again. So these are the possible ways he can travel on Monday, on Tuesday, and on Wednesday. I'm explaining this because I won't draw the tree diagram. If you would love me to draw the tree diagram, maybe you should type it on the comment section and tell me if I should do that. Maybe in the next video. Now, from the first one, traveling by car on Monday, from the question, he said he either travels by car or by train. So the probability that he travels by car or by train must be 1. That means he must travel by car or by train. If he travels by car, the probability that he will travel by train would be 1 minus the probability he travels by car. I don't know if you get that. Since the probability of him traveling by car and train, probability of him traveling by car plus the probability of him traveling by train must be equal to 1, since he must either travel by either of them. So there is a probability that he must either travel by either of them. That is 1. So when finding the probability of him traveling by car, you will subtract by taking this to the other side. You will say 1 minus the probability of him traveling by train. So put that in your head. So from the question, it says there is a probability of 2/3 that he travels by train on Monday. This is Monday. Now the probability of him traveling by train, by car for first. By car, we don't know. But by train, it says it's 2/3. But from this formula I just generated, we can actually solve for car, which would be 1 minus 2/3, and that is 1/3. Now we get that he travels, the probability of him traveling by car on Monday is 1/3, and the probability of him traveling by train on Monday is 2/3. Now, for Tuesday, we are actually asked from the question the probability of him traveling by car on Tuesday, by train on Tuesday, by car on Wednesday, and by train on Wednesday. We are not asked for this, but we absolutely need this. For Tuesday, the probability of him traveling by car on Monday, this is Monday, probability of him traveling by car on Monday multiplying the probability of him traveling by car on Tuesday. Probability of traveling by car on Monday is what? Is 1/3 times probability of him traveling by car on Tuesday, which we don't know. But from the question, we can actually know that. It says if he travels by car on any one day, there is a probability of 5/6 that he will travel by train the next day. But he travels by car on a day called Monday, and the next day he traveled by car again. But from the question, it says 5/6 that he will travel by train the next day. This is car, this is not train. So the probability of train would be 1 minus the probability of car rather would be 1 minus the probability of train, which is 5/6, and that would be 1 minus 5/6. That would be 1/6. Now this should be in a bracket. This is the probability of car on Monday, which is 1/3 from here. And this is the probability of car after traveling by car on Tuesday. Note from the question, we are asked from question 1. It says by car on Tuesday. We should look at Tuesdays and look at the ones that have cars on Tuesday. These have car on Tuesday. These also have car on Tuesday. Then the way we can actually solve for car on Tuesday is when we multiply like this the probability of Monday times the probability of car on Tuesday plus the multiplication of this as well. That is how we can have the probability of him traveling by car on Tuesday. Likewise, if we are to find the probability of him traveling by train on Tuesday, you have to multiply this as well and add it with this, because this is for Tuesday, and this is for Tuesday. The one before is for Monday. The one before is for Monday. The one before is for Monday. Just as this. So now, from here, we know that the probability of him traveling by car on Monday is 1 over 3. From the question, we know that if he travels by car on any one day, the next day, there is a probability of 5 over 6 that he travels by train. But now, we are not looking for the train here. We are looking for him traveling by car on any one day and traveling by car the next day. Now, for car the next day, I said, since this is train, it should be 1 minus train. 1 minus 5 over 6. And that is 1 over 6. Plus the probability of him traveling by train on Tuesday from here, that is equals to 2 over 3 plus m times. What is the probability of him from the question traveling by train on Tuesday and the next day traveling by car? Traveling by train on any one day and the next day traveling by car. From the question, you get that if he travels by train on any one day, which could be Monday, Tuesday, and any day, there is the probability of 3 over 4 that he travels by car the next day. So from here, he travels by train this day, which was Monday, and the probability of him traveling by car the next day from this question is 3 over 4. And then we write down the 3 over 4. We write down the 3 over 4 and we multiply. This should be 1 over 18 plus this is 1 over 2. Now, adding them up, we have 5 over 9, I think. Right? So now we have found the probability of him traveling by car on Tuesday. Now for him traveling by train on Tuesday, we don't need to go through the stress of finding this and this. This is him traveling by train on Tuesday and him traveling by train on Tuesday. But we don't need to go through that. Since we already have him traveling by train and by car on Tuesday, we can as well use this formula again. Now finding the probability of train on Tuesday, we will say probability of train on Tuesday equals 1 minus probability of car on Tuesday. So this is probability of car. This is probability of car on Tuesday from the question. Now probability of train on Tuesday, probability of train on Tuesday would be 1 minus 5 over 9. And this is equals to 4 over 9. So now we have found the first and the second question, which is 5 over 9 and 4 over 9. Now we should go for Wednesday. For Wednesday, he travels from this question. It says find the probability of him traveling by car on Wednesday. We should focus on finding probability of traveling by car on Wednesday. Now, those ones that have cars on Wednesday, these have car 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 on Wednesday. These are the 4 ones, the 4 events we are adding up to get the probability of him traveling by car on Wednesday. Now, from the first one, we have him traveling by car on Monday, traveling by car on Tuesday, and traveling by car on Wednesday. Now, what is the probability of him traveling by car on Monday? That is 1 over 3. This is in the bracket, times. What is the probability of him traveling by car on Tuesday? This is him traveling by car on Tuesday, which we found here. And that is 5 over 9 times. Now, we don't know the probability of him traveling by car on Wednesday. But from the question, once again, it says the probability, if he travels by car on any one day, look, he travels by car on Tuesday, yeah. He said there is a probability of 5 over 6 that he travels by train the next day. Now, if he travels by car on Tuesday, there will be a probability of 5 over 6 that he travels by train on Wednesday. But this is car. So for car, it will be 1 minus 5 over 6. And that is 1 over 6. Now, you know how it goes. This is plus. Probability of car on Monday would be 1 over 3 times. Probability of train on Tuesday, this is Tuesday, would be 4 over 9 times. Now, probability of car on Wednesday after traveling by train on Tuesday. From this question, it says there is a probability if he travels by train on any one day. Now, from he travels on a Tuesday, it says there is a probability of 3 over 4 that he will travel by car the next day. Now, he traveled by train on Tuesday, and the next day, which is Wednesday, there will be a probability of 3/4 that he travels by car. Now, this should be 3/4 since he traveled by car the next day. Now, adding up again, we would have probability of train on Monday from here. Train on Monday, sorry for that. Train on Monday from here, that is 2/3 times car on Tuesday. Car on Tuesday, this is car on Tuesday. Probability of car on Tuesday, that is 5/9. I didn't write it. This is equals to probability of car on Tuesday. This is 5/9 times probability of car on Wednesday. From what I explained from here, it says if he travels by car on any one day, there is a probability of 5/6 that he travels by train. Now, for car, after traveling by car on Tuesday, probability of car on Wednesday would be 1 minus 5/6, and that is 1/6. Now, plus for the next one, train on Monday would be 2/3 times train on Tuesday. This train on Tuesday will be 4/9 times car on Tuesday. Car on Wednesday rather, sorry. Car on Wednesday. From the question, we know that if he travels by train on any one day, where is it? If he travels by train on any one day, there is a probability of 3/4 that he travels by next day. Now, he traveled by train on Tuesday. There will be a probability of 3/4 that he travels by car on Wednesday, which is this 3/4. Now, add up all the possible events after multiplying inside. I would love to skip that. Now, from this whole thing, I got this is 5. 5/162. This is from here. From the second one, I got 1/9 from here. From the third one, I got 5/81 from here. The fourth one, I got 2/9. Now, adding them up, we'll get that the probability of him traveling, this is for car. We have been looking for the probability of car. We sum them up. The probability of him traveling by car on Wednesday, on Wednesday, on Wednesday, will be equals to 23/52 after summing them up. Now, probability of him traveling by train on Wednesday. We can as well go through this stress, but why should we when there is a formula to actually skip that? We can as well go through the stress of finding the probability of this, adding it to this, and adding it to this and this, because they actually have the train on Wednesday in them. So, but not to go through that stress, from this formula to find the probability of him traveling by train on Wednesday, would say the probability of him traveling by train on Wednesday is equals to, taking this to the side, we say 1 minus probability of him traveling by car, which we already got as 23/52. So probability of him traveling by train on Wednesday is equals to 1 minus 23/52. That would be 27. That would be 31/52. So these are the probabilities of him traveling by by car on Tuesday 5/9, by train on Tuesday 4/9, by car on Wednesday 23/52, by train on Wednesday 31/52. So I hope this helps someone. If you actually want me to draw this tree diagram in the next video, there is no problem. You drop it at the comment section. I will look forward to doing that. Thank you for watching this video. Please subscribe.